everyone, myself Henasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of multiple integrals, right? So let us begin with the first topic, that is area in Cartesian coordinates. So the area A bounded by the curves y is equals to f1 of x and y is equals to f2 of x, intersecting at the points P of A comma B and Q of C comma D. That is, we are given two curves in our Cartesian plane, that is our xy plane. So the first curve is y is equals to f1 of x, right? And the other curve is y is equals to f2 of x, right? Which is intersecting at point P is equals to A comma B and Q is equals to C comma D. So we have to find the area bounded by these curves, right? So this is our region R. Okay, so we can consider two types of strip. One is horizontal strip. So this is our horizontal strip which gives us limit of x, and consider this vertical strip to find the limit of y, right? So our area A will be given by double integration. Firstly put the limits of x. So the limit of x is starting from A and ending at C. So the limit will be x is equals to A to x is equal to C. Now consider this vertical strip, right? So our limits of y will be f1 of x to f2 of x, dy dx, right? Similarly, if the equations of the curves are represented as x is equals to g1 of y, that is, if x is given as a function of y and x is equals to g2 of y, then our area will be given by double integration from y is equals to b2d, x is equals to g1 of y to g2 of y dx dy. Okay. Now let us study area in polar coordinates. Okay. So the area bounded by the curves r is equals to f1 of theta and r is equals to f2 of theta, and the lines theta is equals to theta 1 and theta is equals to theta 2. Here consider r and theta plane, right? So this is our initial line, theta is equals to 0. This is our line, theta is equals to pi by 2. Now draw two curves of this type where this is r is equals to f1 of theta, this is equals to r is equals to f2 of theta, and consider two lines, right? Theta is equals to theta 1 and theta is equals to theta 2. So this is our region bounded between two curves in the polar coordinates, right? So our area will be given by theta is equals to theta 1 to theta 2, r is equals to f1 of theta to f2 of theta, r dr d theta. So dx dy is replaced by what? R dr d theta. So this is our formula to find area in polar coordinates. Okay. So now let us find the area enclosed by the curve y is equals to x square and y is equals to x. So here we have to find the area bounded by the parabola and the line y is equals to x. Okay. So let us start the solution. So firstly we will find the point of intersection of the parabola y is equals to x square and the line y is equals to x. Okay. So now let us consider y is equals to x square. Now our y is equals to what? X. So what we can write? X is equals to x square. So now take this x on this side. So what we will get? X square minus x is equals to 0. Now take out x common and factorize. So what you will get? X into x minus 1 equals to 0. So what? From this we can say that the values of x are 0 and 1. Okay. Now what we have? Y is equals to x, right? So whenever x is equals to 0, y is also 0. Whenever x is equals to 1, y is also 1. Okay. So from this our points of intersection are 0, 0 and 1, 1. Okay. So now let us draw the graph of the parabola and line. So this is our graph of the parabola y is equals to x square. Now draw the line y is equals to x. Okay. Now we know the point of intersection of the line and parabola is origin and 1, 1. Right. So let us draw a strip, vertical strip AB, right? So from this, our limit of y will be y is equals to x square to x, right? From the strip AB, we can say that our limits of y are y is equals to x square to y is equals to x. And our limit of x will start from 0 to x is equals to 1, okay? So limits of x are 0 to 1, okay? So now our area will be given by double integral. Firstly consider x square to x, then put our limit which has numerical values. They are 0 to 1 dy dx, right? Why we have written dy dx? Because y is of the form f1 of x and f2 of x, right? So our formula of area will be this. Now firstly let us integrate with respect to y. Okay, so answer will be y and the limits are x square to x, and this will remain as it is, that is integration 0 to 1 dx. Okay, so now let us put the limits in place of y. So put the upper limit, so you will get x minus the lower limit, that is x square dx. Now just do the integration of this with respect to x. So the integration of x will be x square by 2 and the integration of x square will be x cube by 3 and your limits are 0 to 1. Okay. So now let us put the limit. Firstly put 1. So what you will get 1 by 2 minus 1 by 3. On putting 0, the whole term will go to 0, right? So finally on simplification you will get your answer of the area bounded between the parabola and the line y is equals to x as 1 upon 6. Okay. So now let us solve one more example. Here we have to find the area enclosed between the curves r is equals to 2 and r is equals to 4 in the first quadrant. So here we are given two circles of radius 2 and 4 and we have to find the area between these two circles only in the first quadrant, right? So let us start with the solution. So here the region of integration is the interior of the circles between r is equals to 2 and r is equals to 4. Right? So firstly draw a circle of radius r is equals to 2. So this is the circle of radius r is equal to 2. Now the outer circle you can see here is of radius r is equals to 4. Right? Now our theta ranges from 0 to pi by 2 because we have to consider only first quadrant, right? So our region R is this. Okay. Now we have to draw an elementary radius vector OAB. So we have to draw this elementary radius vector, right, from the origin which enters in the region. So this enters in the region from r is equals to 2 and leaves the circle at r is equals to 4. Okay, so from this we can say that our limit of r is equals to 2 to r is equals to 4 and our theta is going from theta is equals to 0 to theta is equals to pi by 2. Okay, so now let us find the area. So the formula of area is A is equals to, put the limit of theta 0 to pi by 2, put the limits of r, they are 2 to 4, r dr d theta, right? So firstly we have to evaluate the integral with respect to r, right? Keeping theta as it is. So on integration what you will get? R square by 2, put the limits 2 to 4, d theta will remain as it is and this integration also will remain as it is. Firstly put the value of r as what? 4. So what you will get answer as 8 minus put the lower limit, that is 2. So you will get the answer as 2 and again integration 0 to pi by 2 and d theta will remain as it is. So now simplify this and take 6 outside. So 6 times integration of 1 d theta will be theta, limits are 0 to pi by 2. Okay, so again put the limits of theta. So it will be pi by 2 minus 0, right? And 6 outside. So you will get 6 times pi by 2. Now these two will get cancelled out. So the area in the polar coordinates will be equals to what? 3 pi, right? So this is our area bounded between the circles r is equals to 2 and 4 in the first quadrant. Okay, so now let us go to our next topic, that is double integrals as volume. We have to find volume using double integrals, right? So when a surface z is equal to f of x comma y is continuous on the region R and f of x comma y greater than equals to 0 for all x comma y in the region R, then double integral over R f of x comma y dA is the volume of the solid region between the surface z is equals to f of x comma y and the region R in the xy plane. Okay. So, the formula to find the volume in the Cartesian coordinates, that is xy plane, using double integrals is given by v is equals to double integral over r. Now here your f of x comma y is what? Z. So write z dx dy. Okay. And next, the formula to find the volume in polar coordinates using double integrals is given by v is equals to double integral over r. Z will remain as it is. Just replace dx dy by what? R dr d theta. So these two are the formulas to find the volume using what? Double integrals. So now let us solve one more example. So here we have to find the volume bounded by the cylinder x square plus y square is equals to 4 and the planes y plus z is equals to 4 and z is equals to 0, right? So now let us start with the solution. So here we are given z is equal to 0. So the lower limit of z will be 0 and from this the upper limit of z will be what? 4 minus y. So our region is bounded by the cylinder and these two planes, right? So what will be formed? A circle x square plus y square is equals to 4, right? So this is the region where our volume is to be derived, right? So let us find the volume. So, volume V will be given by double integral over R z dx dy. So, it will be equals to 2 times double integral over R. Now, z is what? 4 minus y dx dy. Now, using polar coordinates, right? Our limits of R will be what? 0 to 2 because x square plus y square is equals to 4, right? So, keeping x as r cos theta and y as r sin theta. From this we can derive that r square is equals to 4, therefore r is equals to what? 2. So limits of r are from 0 to 2 and limits of theta are what? Minus pi by 2 to pi by 2. So on putting the limits, our volume V will be equals to what? 2 times integration minus pi by 2 to pi by 2, integration 0 to 2, 4 minus, put the value of y, that is r sin theta, right? So minus r sin theta, replace dx dy by what? R dr d theta, right? Now take this r inside, so what you will get? 4r minus r squared sin theta dr d theta, okay? So now we have to integrate this with respect to r first, keeping theta constant. So this sin theta will remain constant. So integration of this term will be what? 4r square by 2 minus sin theta will remain constant and integration of r square will be what? R cubed by 3 and the limits are 0 to 2. Okay, so now let us put the limits in place of r. So finally the answer of the volume will be 2 times integration minus pi by 2 to plus pi by 2. 8 minus 8 by 3 sin theta d theta. Okay, now we will integrate with respect to theta. But sin theta is an odd function, right? So integration from minus pi by 2 to plus pi by 2. Sin theta d theta will be equals to what? 0. because sine is an odd function, right? So our volume will be what? 4 times integration 0 to pi by 2 8 d theta, right? We have converted this into 2 times integration 0 to pi by 2 8 d theta, right? So again here 2 is there, so 2 into 2 will become 4. Okay, so now just integration of 1 d theta will be equals to what? Theta, and the limits are 0 to pi by 2, and 4 into 8 will be what? 32. On final simplification, our volume V is equals to what? 16 pi. Okay, so I hope you have understood throughout the session. Thank you for watching.